The afternoon sun beat down on Dallas-Fort Worth International Airport on June 2, 1983. Gate agents processed the final boarding passes as passengers filed onto Air Canada Flight 797, a McDonnell Douglas DC-9 bound for Montreal with a scheduled stop in Toronto. Nobody boarding that day could have imagined they were about to experience one of aviation's most harrowing disasters. A tragedy that would fundamentally reshape how the industry approaches in-flight fires. Among the 41 passengers settling into their seats were business travelers heading home, families starting summer vacations, and individuals with their own stories and destinations. They trusted that the aircraft beneath them was airworthy, that the crew was competent, and that the systems designed to protect them would work as intended. On 2 of these counts, they were absolutely right. On the 3rd, they were tragically, fatally wrong. The aircraft, a troubled history. The DC-9 waiting at the gate that day wore the distinctive red maple leaf of Air Canada. But beneath its polished exterior lay a history of problems that should have raised more red flags than it did. Aircraft registration CFTLU had been in continuous service with Air Canada since its delivery 15 years earlier in 1968. In the world of commercial aviation, 15 years isn't necessarily old. Many aircraft fly safely for decades. But this particular airframe had endured an incident 3 years prior that would prove eerily relevant. In 1980, as the same DC-9 climbed through its cruising altitude after departing Boston, the aft pressure bulkhead, the critical structural component that keeps the cabin pressurized, suddenly failed. The explosive decompression that followed was violent and destructive. Air rushed out of the cabin at tremendous speed, carrying with it debris that tore through flight control systems, hydraulic lines, and electrical wiring. The damage was so extensive that the aircraft spent months in maintenance, with technicians replacing entire sections of the aft cabin, including both rear lavatories. Most critically, workers had to splice together numerous bundles of electrical wiring. This repair work, while presumably done to standard, created a complex web of connections behind the cabin walls, connections that would be hidden from view, difficult to inspect, and potentially vulnerable to the kind of wear and degradation that can occur over time in the harsh environment of an aircraft cabin. The maintenance logs told another troubling story. In the year leading up to Flight 797's final journey, technicians had logged 76 separate entries related to problems with the aircraft's electrical generators, both the main engine-driven units and the auxiliary power unit. 76 failures in a single year. That's more than one every 5 days on average. For any aircraft, this represents a pattern that should trigger deeper investigation. Whether it ever did remains unclear. The crew, experience, and competence. If the aircraft itself carried hidden vulnerabilities, the crew at least represented the very best of Air Canada's flight operations. Captain Donald Cameron, at 51 years old, embodied the stereotype of the experienced airline captain. With 13,000 flight hours accumulated over a 17-year career with Air Canada, including nearly 5,000 hours specifically on the DC-9, Cameron was exactly the kind of pilot passengers hope to have up front when things go wrong. His first officer, 34-year-old Claude Ouimet, brought his own impressive credentials to the cockpit. 10 years with Air Canada had given him 5,500 total flight hours, with roughly half of those on the DC-9. The 2 men had flown together before and worked well as a team, their communications smooth and professional. In the cabin, 3 flight attendants prepared for what they expected to be a routine 3-hour flight. Lead flight attendant Sergio Benetti, along with his colleagues Laura Kiyama and Judy Davidson, had all been trained in emergency procedures, including how to fight fires. That training emphasized a particular type of fire, the lavatory waste bin fire caused by carelessly discarded cigarettes. In 1983, smoking was still permitted on commercial flights, and waste bin fires, while concerning, were not uncommon. The flight attendants had the equipment to handle them: portable fire extinguishers, smoke goggles, and clear procedures to follow. What none of them had been trained for, what nobody in the industry had really conceptualized, was a fire hidden behind cabin walls, fed by the aircraft's own wiring, growing in intensity in spaces where no fire extinguisher could reach it. Departure. Everything seems normal. At 4:09 p.m. local time, Flight 797 pushed back from its gate. The pre-flight checks had revealed no significant problems. The troublesome generators that had caused so many issues were, for the moment, working properly. The engines started normally, and the aircraft taxied out to runway 17L. The weather was typical for a Texas summer, hot, with towering cumulus clouds building over the plains, but nothing that would trouble a modern jet aircraft. At 4:25 p.m., Captain Cameron advanced the throttles, and the DC-9 accelerated down the runway, lifting off smoothly into the afternoon sky. The climb out took them through scattered clouds as the pilots navigated around the buildups of thunderstorm activity. By the time they leveled off at their cruising altitude of flight level 330, approximately 33,000 feet, they were above the weather in smooth, clear air. The first hour of the flight passed uneventfully. The autopilot flew the aircraft along its planned route while Cameron and Ouimet monitored the systems and navigated around weather ahead. In the cabin, flight attendants began their service, moving through the aisle with the beverage cart, taking meal orders and chatting with passengers. At approximately 5:45 p.m., as the aircraft cruised over Louisville, Kentucky, First Officer Ouimet was eating his crew meal, steak and seafood, though he would later remark that the steak was somewhat dry. It was the kind of mundane observation that would stick in his memory because of what was about to happen. The first sign, circuit breakers pop. The sound was distinctive, a rapid series of clicks from behind Captain Cameron's seat. Both pilots turned to look at the circuit breaker panel, a board filled with dozens of small buttons, each one designed to cut electrical power to a specific piece of equipment if that equipment starts drawing too much current, potentially overheating and starting a fire. 3 circuit breakers had popped out, and they were all related to the same system, the flush motor for the aft lavatory toilet. Cameron reached over and tried to reset them, pushing each breaker back in. But they wouldn't stay. As soon as he released pressure, they popped back out with that same clicking sound. He tried again. Same result. The breakers were tripping instantly, which meant that whatever was causing the problem wasn't going away. The pilots discussed the situation. The most likely explanation seemed obvious. A passenger had probably stuffed something down the toilet, paper towels, perhaps, or some other debris, jamming the flush motor. The motor, unable to turn, would draw excessive current as it tried to operate, causing the circuit breakers to trip as designed. It was an annoyance, nothing more. The aft lavatory would be out of service for the remainder of the flight, and the maintenance team in Toronto would deal with it on the ground. Cameron pulled out the aircraft's maintenance log and began making an entry. The time was noted, approximately 5:51 p.m. They were now roughly 1 hour and 26 minutes into their flight, with about an hour and a half remaining until their scheduled arrival in Toronto. Neither pilot could have known that 90 feet behind them, hidden behind the lavatory's wall paneling, something far more sinister than a jammed toilet motor was occurring. The circuit breakers hadn't tripped because of a mechanical problem. They had tripped because electrical wiring behind that lavatory wall was shorting out, arcing, generating tremendous heat, and beginning to set fire to the materials around it. The situation develops normalcy bias. For the next 9 minutes, the flight continued normally. The pilots discussed the circuit breaker issue, made their log entry, and moved on to other tasks. Cameron tried resetting the breakers one more time at 6 p.m. with the same result. They popped right back out. He made a mental note to inform maintenance and left the breakers alone. This decision point is worth examining because it illustrates a fundamental challenge in aviation safety, and indeed in many complex systems. Human beings are pattern recognition machines. We're excellent at identifying familiar situations and responding with appropriate, practice solutions. But this same capability can work against us when we encounter novel situations that superficially resemble familiar ones. The popped circuit breakers fit a pattern both pilots recognized. Minor electrical annoyances on an aircraft with a history of minor electrical annoyances. The maintenance log was full of generator problems, electrical glitches, and similar issues. In that context, 3 tripped breakers related to a toilet flush motor seemed to fit right in. It was just another entry for the maintenance team to deal with. Psychologists call this normalcy bias, the tendency to underestimate the possibility of disaster and to interpret warning signs as normal variations rather than harbingers of catastrophe. It's the reason people sometimes ignore fire alarms, assuming they're false alarms or drills, or fail to evacuate when first warned of approaching danger, assuming authorities are being overly cautious. The pilots of Flight 797 weren't being careless or negligent. They were being human, interpreting ambiguous information through the lens of their experience and expectations. And for now, those expectations suggested a minor problem, nothing more. Behind them, the fire grew. Discovery, the smell of smoke. At approximately 6:03 p.m., passengers seated near the rear of the aircraft began noticing something wrong. There was a smell, acrid, chemical, unmistakably the smell of something burning. One passenger flagged down flight attendant Laura Kayama and mentioned the odor. Other passengers nearby confirmed they could smell it too. Kayama moved toward the aft lavatory, the most likely source. Cautiously, she opened the door just a crack, not knowing what she might find. What met her was a wall of gray smoke, thick enough that she couldn't see inside the small compartment. She immediately closed the door and alerted lead flight attendant Sergio Benetti. Benetti's training kicked in. A fire in the lavatory meant most likely a waste bin fire, a cigarette that hadn't been fully extinguished before being thrown away. The procedure was clear. Grab a fire extinguisher, open the door, and put out the fire. He retrieved a halon extinguisher from its mounting point and returned to the lavatory. Opening the door more fully this time, Benetti discharged the extinguisher into the smoke-filled space, directing the chemical agent at the waste bin and paying particular attention to the seams where the walls met the ceiling, where he could see smoke emerging. He couldn't see any flames, which struck him as somewhat odd, but he used nearly the entire extinguisher before closing the door again. The halon extinguisher, a type of fire suppression system that works by chemically interrupting the combustion process, should have been effective against a waste bin fire. Benetti had done everything by the book. But as he stood outside the closed lavatory door, catching his breath, something felt wrong. The smoke had been thicker than he'd expected, and it hadn't seemed to be coming from the waste bin at all, but rather from behind the walls. The pilots are informed. Decisions under uncertainty. A flight attendant arrived in the cockpit with urgent news. There was a fire in the aft lavatory, and Benetti was currently fighting it. For Captain Cameron, this was the moment when the situation transformed from a minor electrical annoyance to a potential emergency. An in-flight fire is every pilot's nightmare. Aircraft are, by necessity, filled with flammable materials, seat cushions, carpeting, wall panels, luggage, fuel. They're also sealed containers at altitude, where opening windows or doors is impossible. Statistical analysis of previous in-flight fires had shown a grim pattern. Once a fire becomes established, pilots have an average of only 17 minutes to get the aircraft on the ground before losing control. But here's where information flow, or rather, the lack thereof, began to play a critical role. The message the pilots received was straightforward. Fire in the aft lavatory, being extinguished. What they didn't receive was equally important information. The fire didn't appear to be in the waste bin, and the smoke seemed to be coming from behind the walls. This omission wasn't intentional. In the stress and urgency of the moment, with smoke filling the rear cabin and passengers coughing, the flight attendants were focused on immediate action. The nuances about the fire's apparent location simply didn't get communicated in that first critical message. So Captain Cameron made a decision based on incomplete information. He assumed reasonably, given the circumstances and his training, that this was a waste bin fire. Waste bin fires, while serious, were manageable. Flight attendants were trained to fight them. The fire would be extinguished, the smoke would clear, and the flight would continue to Toronto. To verify this assumption and assess the situation firsthand, Cameron sent First Officer Ouimet back into the cabin to investigate. Ouimet removed his oxygen mask, got up from his seat, and headed aft. As he moved through the cabin, he could see passengers looking concerned but not panicked. The flight attendants had moved passengers away from the aft section. And then he saw the smoke. Even with the passengers relocated, the smoke lingering over the last 3 or 4 rows of seats was thick enough that Ouimet couldn't push through it to reach the lavatory. Without proper breathing protection, the DC-9 wasn't equipped with smoke masks for the pilots. He couldn't get close enough to make an assessment. He turned back, spoke briefly with Benetti, and returned to the cockpit. The critical 15 minutes. Misreading the signs. What Ouimet reported to Cameron was a mixture of concerning and reassuring information. The smoke was thick enough that he couldn't reach the lavatory. That was alarming. But Benetti had told him he'd used the fire extinguisher, and now, as Ouimet glanced back into the cabin from the cockpit, the smoke did appear to be clearing somewhat. The passengers weren't panicking. Some were even ordering drinks from the flight attendants. This improvement in conditions seemed to confirm Cameron's initial assessment. Waste bin fire, now extinguished, smoke dissipating. Crisis managed. But what was actually happening behind those walls was the exact opposite. The fire hadn't been extinguished at all. The halon extinguisher had filled the lavatory compartment with fire suppressant, but the fire was burning behind the walls, in the insulation, in the wiring bundles, in spaces the extinguisher couldn't reach. And it was growing. The reason the smoke appeared to be clearing wasn't because the fire was weakening, it was because the fire was getting stronger. As the flames intensified, they burned through the lavatory's plumbing and ventilation ducts, creating new pathways for smoke to escape into the aircraft's air conditioning system and out through vents rather than into the passenger cabin. From the perspective of anyone in the cabin, it looked like the situation was improving. In reality, it was deteriorating rapidly. Cameron made the decision not to divert. They were over Kentucky, roughly equidistant from several airports. Cincinnati, Louisville, and Indianapolis were all within range. But diverting would mean declaring an emergency, coordinating with air traffic control, briefing the passengers, and dealing with all the logistical complications that come with an unscheduled landing. And for what appeared to be a fire that had already been extinguished, it seemed like an overreaction. This is where the timeline becomes crucial. It was now approximately 6:06 p.m., about 15 minutes since the circuit breakers had first popped. Unknown to the pilots, they were already past the midpoint of the 17-minute average survival time for an aircraft with an established in-flight fire. Ouimet, still not entirely satisfied with the situation, asked Cameron if he could go back again, this time with smoke goggles, to get a better look at the lavatory and confirm the fire was out. Cameron agreed and handed him his own smoke goggles since Ouimet's were inaccessible from his seat position. Ouimet headed aft again. As he made his way through the cabin, Benetti appeared in the cockpit to give Cameron an update. The passengers had been moved forward, he reported, and the smoke was indeed clearing. Everything appeared to be under control. Cameron acknowledged the information, and Benetti returned to the cabin. These reports, the smoke clearing, the passengers calm, the flight attendants confident they'd handled the situation, all reinforced Cameron's decision not to divert. But they were all based on a fundamental misunderstanding of what was happening behind those walls. The situation becomes undeniable. System failures. At 6:09 p.m., everything changed. The master caution light on the instrument panel illuminated, accompanied by warning indicators showing that the left side electrical bus had failed. Suddenly, instruments throughout the cockpit began going dark or showing erratic readings. The heading indicators, critical for navigation, were among the first to fail. For Captain Cameron, this was a confusing development. Was this related to the fire? Or was it another manifestation of the aircraft's ongoing electrical problems? The maintenance log had documented all those generator issues. Maybe one of them had finally failed completely? But then more systems began failing in rapid succession. The aircraft's transponder, the system that tells air traffic control exactly where the plane is and what its altitude and speed are, went offline. On the controller's radar screen at Indianapolis Center, Flight 797's identification data disappeared, leaving only a primary radar return. A simple blip without any additional information. The controller immediately noticed and switched to a backup system to maintain contact. But this was now a clear indication that something serious was wrong with Flight 797. Cameron radioed air traffic control to report an electrical problem and asked them to stand by while he assessed the situation. This is another decision point worth examining. Cameron had multiple pieces of information at this point. Circuit breakers tripping related to the aft lavatory, reports of fire and heavy smoke in that same lavatory now, major electrical system failures. Any one of these alone could be explained away. Together, they painted a picture that should have been clear. There was a significant fire on board, and it was burning through the aircraft's electrical systems. But Cameron still hadn't declared an emergency or begun a descent. Why? Partly because of the conflicting information he'd received about the smoke clearing. Partly because of the aircraft's history of electrical problems, which suggested this might be another non-fire-related issue. And partly because of the sheer cognitive difficulty of accepting that the worst-case scenario, the nightmare scenario every pilot trains for but hopes never to face, was actually happening. Then, at 6:11 p.m., First Officer Ouimet reached the aft lavatory with his smoke goggles on. He reached for the door handle to check inside the compartment. The metal was hot to the touch. Very hot. The fire was not out. It had never been out. Ouimet immediately told the flight attendants not to open that door under any circumstances and hurried back to the cockpit. As he rushed forward, the master warning light illuminated in the cockpit. More serious than the caution light that had come on minutes earlier. This time, the warning indicated that both emergency electrical buses had lost power. The two attitude indicators, the instruments that tell pilots whether the aircraft's nose is up or down and whether the wings are level or banked, began to fail. These are among the most critical flight instruments, especially when flying in clouds or at night when visual references are unavailable. Losing them is a pilot's nightmare. Emergency descent, the race against time. Ouimet burst into the cockpit and told Cameron in urgent terms, "We need to get down now." The tone, the urgency, the stark seriousness in his first officer's voice told Cameron everything he needed to know. This wasn't a minor problem. This was a life-threatening emergency. Cameron's training and experience took over. His left hand pulled the throttles back to idle. His right hand pulled the speed brake handle back, deploying panels on the wings to increase drag. He pushed the control column forward, pitching the aircraft's nose down into a steep descent. At the same time, he keyed his radio microphone. "Indianapolis. Air Canada 797. We have an emergency. We have a fire on board and we're descending." The controller's response was immediate and professional. "Air Canada 797. Roger. I show you 25 miles from Greater Cincinnati. Can you make Cincinnati? 25 nautical miles. Under normal circumstances, that's barely 10 minutes of flight time. But Flight 797 was at 33,000 feet. To land at Cincinnati, they would need to descend more than 6 miles vertically while covering those 25 miles horizontally. It would require one of the steepest descents a commercial airliner can perform." "Affirmative," Cameron responded. "We can make Cincinnati. Air Canada 797. Descend and maintain 5,000. Cameron acknowledged and pushed the aircraft into an even steeper dive. The altimeter began unwinding rapidly. The vertical speed indicator, which shows how fast the aircraft is climbing or descending, pegged at its maximum reading of 6,000 feet per minute. The actual descent rate was almost certainly higher. The aircraft plunged into a thick layer of clouds at 25,000 feet, and suddenly the pilots were flying on instruments alone, unable to see anything outside their windows except gray mist. The speed built rapidly. 310 knots indicated airspeed, close to the aircraft's maximum operating speed. The controls shook with the forces of air rushing over the airframe. Cameron had pulled the speed brake handle to its maximum extension, but the sheer speed of the descent forced the panels back into their retracted position. In the cabin, passengers felt their stomachs rise as the aircraft pitched downward. Those who had been calm moments ago now gripped their armrests as the descent continued, steeper and more urgent than any they'd experienced before. The cabin's air pressure began to change rapidly, causing ears to pop painfully. The fire spreads. Toxic smoke. As the aircraft descended through 25,000 feet, the situation in the cabin deteriorated rapidly. Smoke that had seemed to be clearing minutes ago now returned with a vengeance, pouring from ceiling vents, from the seams around overhead bins, from every gap and crack in the cabin structure. This smoke wasn't the simple byproduct of burning paper or fabric. It was the toxic output of burning plastics, melting insulation, vaporizing wiring insulation. It contained carbon monoxide, hydrogen cyanide, and countless other poisonous compounds. Passengers began coughing violently, their eyes burning, their throats constricting. The flight attendants moved through the cabin, trying to provide what comfort they could, but they were as affected by the smoke as the passengers. The cabin temperature was rising as well. The fire burning behind the walls was generating tremendous heat, and that heat was radiating into the passenger compartment. The flight attendants made a crucial decision: move all passengers as far forward as possible, away from the source of the smoke. Passengers were directed to relocate to the front rows, bunching together, leaving the entire aft section of the cabin empty. This would give them the best chance of surviving if they could just get the aircraft on the ground. The flight attendants also began opening the individual air vents above each seat, trying to create an airflow that would push the smoke toward the rear of the aircraft. It was a small measure, but it was something. Every breath of clearer air mattered now. Systems cascade. The aircraft falls apart. At 6:13 p.m., as the aircraft passed through 15,000 feet in its emergency descent, the emergency power inverter failed. This was the backup system that First Officer Ouimet had activated minutes earlier to restore power to critical instruments. Its failure meant that those instruments were once again without power. Both attitude indicators went dark. The magnetic compasses stopped working. The navigation instruments showed nonsensical readings or nothing at all. Cameron was now flying the aircraft almost blind, relying on just 3 instruments: a small backup attitude indicator about the size of a coffee cup, the altimeter showing his altitude, and the airspeed indicator showing his speed. Flying an aircraft under normal circumstances requires constant reference to multiple instruments: attitude, heading, altitude, airspeed, vertical speed, engine instruments, and more. Pilots scan these instruments constantly, building a mental picture of the aircraft's state and trajectory. To lose most of these instruments while descending in clouds, fighting a fire, with smoke filling the cockpit, while trying to communicate with air traffic control through an oxygen mask, represents a level of task saturation that's difficult to comprehend. But Cameron had one more problem. The horizontal stabilizer at the rear of the aircraft had stopped working. This large surface normally provides the primary means of controlling the aircraft's pitch, nose-up or nose-down attitude. With electrical power lost to its control system, it had frozen in position. Cameron now had only the elevators, much smaller control surfaces mounted on the trailing edge of the stabilizer, to control pitch. This made the control column incredibly heavy. To pitch the nose up or down now required tremendous physical force. Cameron was essentially arm wrestling the aircraft, using muscle strength to overcome aerodynamic forces that the stabilizer trim system normally handles effortlessly. For a man in his 50s, wearing an oxygen mask, peering through smoke to see his instruments, this was an enormous physical challenge on top of everything else. The confusion, misidentified aircraft. While all of this was happening, a separate problem was developing with air traffic control. When the Indianapolis Center controller had handed off Flight 797 to the Cincinnati approach controller, both controllers had been using primary radar, the backup system that only shows aircraft positions, not their identities. The approach controller, seeing multiple targets on his screen, had mistakenly identified the wrong aircraft as Flight 797. Based on that aircraft's position, he began planning to land Flight 797 on runway 36, Cincinnati's northern runway. He even informed the airport's fire crews to position themselves near runway 36. This confusion would continue for several more minutes, with the controller giving instructions that didn't quite make sense to Cameron because they were actually intended for a completely different aircraft. Eventually, the controller asked Cameron to make a left turn so he could confirm which radar target was the correct one. Cameron complied, and the controller finally realized his error. But now there was a new problem. Flight 797's actual position, based on the correct radar target, was only 8 miles south of runway 36, and the aircraft was still at 8,000 feet. That was far too close and too high to land safely. The controller would need to vector the flight around to a different runway. He chose runway 27 left, Cincinnati's primary westerly runway. But to get there, Cameron would need to fly an extended path around the airport's south side, adding precious minutes to the approach. Minutes that Flight 797 might not have. The cockpit fills with smoke. Visibility approaches zero. As First Officer Ouimet moved back and forth between his seat and the cabin, he had left the cockpit door open. His reasoning was sound. It made communication with the flight attendants easier, and they might need to relay urgent information. But it also meant that smoke from the cabin was now pouring into the cockpit. Both pilots had their oxygen masks on, which provided them with breathable air. But the masks didn't do anything about visibility. The smoke was now so thick in the cockpit that Cameron could barely see his instruments. He had to lean forward, squinting, holding checklists up to within inches of his face to read them. His smoke goggles kept fogging up from the heat and his own perspiration. He would have to take them off, wipe them clean while the smoke stung his eyes, and put them back on. All of this while flying the aircraft manually, without most of his instruments, with controls that required tremendous physical force to move. Ouimet was trying to help, running through emergency checklists, communicating with air traffic control, but the sheer workload was overwhelming. They needed to configure the aircraft for landing, extending flaps, lowering landing gear, calculating approach speeds, all while fighting the fire's effects and preparing for an emergency evacuation. In a moment of desperation, First Officer Ouimet made a decision that he believed might help but which actually made things worse. He switched off the aircraft's air conditioning packs. His reasoning was that these packs bring in outside air to the cabin, and that air might be feeding the fire with oxygen. Turn them off, he thought, and maybe the fire would burn less intensely. But the air conditioning packs serve another critical function. They continuously refresh the cabin air, removing smoke and bringing in breathable air from outside. With them turned off, the aircraft became essentially a sealed container. The smoke had nowhere to go. It continued building up, becoming thicker and thicker, while the fire consumed what oxygen remained and generated more toxic gases. The cabin temperature continued to rise. Near the ceiling, invisible to anyone, combustible gases were accumulating, gases that, given the right conditions, could ignite in a flash fire that would consume everything in an instant. The approach, flying by faith. At 6:16 p.m., Cameron leveled the aircraft at 3,000 feet. They had descended 30,000 feet in just over 5 minutes, an astonishing rate of descent that had brought them close to the aircraft's structural limits. But they were still in clouds. Cameron couldn't see the ground, couldn't see the airport, couldn't see anything except the gray mist outside his windows and the smoke inside his cockpit. The approach controller was vectoring them toward runway 27 left, giving heading instructions, turn left heading 270. But Cameron had no heading indicator. His compass was dead. He had no idea which direction he was flying except in the most general sense. The controller adapted, giving simpler instructions, turn left, okay, stop your turn. Cameron complied, turning the aircraft by reference to his tiny backup attitude indicator, which showed him only whether his wings were level or banked, not which direction he was heading. It was like trying to navigate through a city while blindfolded, with someone giving you directions by saying only, turn left or turn right, without any street names or landmarks. Every turn had to be done on faith, faith in the controller's instructions, faith in his own ability to interpret them correctly, faith that they were still heading toward the runway and not away from it. Air Canada 797, you're 12 miles from the airport, the controller reported. 12 miles. Maybe 6 or 7 minutes if everything went perfectly. But would the aircraft remain controllable for 6 more minutes? Would the fire break through into the cabin? Would the passengers survive that long in the toxic smoke? Cameron called out for Ouimet to depressurize the cabin. This was a critical decision. Aircraft cabins are normally pressurized to the equivalent of about 8,000 feet elevation even when cruising at 30,000 or 40,000 feet. This pressurization is maintained by limiting how fast air can escape from the cabin. To depressurize means to open the outflow valves and let the cabin pressure equalize with the outside pressure. Why would Cameron want this? Because if they landed while the cabin was still pressurized, the pressure difference between inside and outside would make it extremely difficult, perhaps impossible, to open the doors for evacuation. The doors would be held shut by thousands of pounds of force from the pressure differential. Cameron needed to eliminate that problem before landing. But depressurizing also meant that some of the smoke would vent out of the aircraft, which sounds good except that it would be replaced by Nothing. With the air conditioning packs off, no fresh air was coming in. The passengers and crew would be breathing an increasingly oxygen-depleted atmosphere while toxic gases continued to build up. Ouimet opened the outflow valves. The change in pressure was subtle at this low altitude, but some smoke did stream out of the aircraft. The passengers barely noticed, too focused on trying to breathe through wet towels that flight attendants had distributed, too focused on the terror of not knowing whether they would survive the next few minutes. The final minutes. Breaking out of the clouds. At 3,000 feet, still in clouds, still unable to see anything, Cameron pushed the aircraft into another descent. They were too high, flying too fast, covering ground too quickly. The controller had them on a long downwind leg that would eventually turn them onto final approach for runway 27 left, but every second they spent at altitude was another second the fire had to spread, another second closer to losing control entirely. Air Canada 797, descend to 2,500 feet. Cameron pushed the nose down again, and the aircraft resumed its rapid descent. His hands ached from the force required on the controls. His eyes burned from the smoke. The heat in the cockpit was becoming oppressive. But he kept flying, kept the aircraft under control, kept believing that he could get it down. At 2,500 feet, they finally broke out of the clouds. Suddenly, the ground was visible below them, the landscape of suburban Cincinnati spreading out in the fading evening light. But where was the airport? Cameron scanned the horizon, looking for the familiar sight of runway lights, the rectangular outline of the airfield. Nothing. Air Canada 797, the airport is 12 o'clock, 10 miles. The controller reported, meaning directly ahead. Cameron stared straight ahead, willing the airport to appear. The approach controller had ordered the runway lighting turned to maximum intensity to help them spot it. And then, finally, with about 2 miles to go, Cameron saw it. 2 parallel ribbons of white light, runway 27 left and runway 27 right. It was the most beautiful sight he'd ever seen. They were going to make it. Gear down, he commanded. Ouimet moved the landing gear lever, and they felt the reassuring thump and drag as the main gear and nose gear extended and locked into place. Cameron extended the flaps further, slowing the aircraft, configuring it for landing. The aircraft was incredibly difficult to control with the frozen stabilizer. Cameron had to use almost all his strength to keep the nose at the right attitude, to keep the aircraft descending at the right rate. The throttles were set by feel. He no longer had reliable engine instruments to tell him the thrust level, but he'd flown the DC-9 for thousands of hours. He knew the sound the engines should make, the feel they should have. In the cabin, flight attendants shouted instructions to passengers who could barely hear them over the roar of the engines and the rush of air. Everyone was to adopt the brace position, heads down, hands over their heads, prepared for a hard landing. Many passengers were already slumped in their seats, overcome by smoke inhalation, barely conscious. The cabin crew knew they would have only seconds to evacuate once the aircraft stopped. If the fire broke through into the cabin while they were still moving, while the doors were still closed, everyone would die. Their only chance was for Cameron to get the aircraft on the ground and stopped quickly enough that they could open the doors and get everyone out before the inevitable happened. Touchdown, the landing. The DC-9 crossed the runway threshold at approximately 6:19 p.m., 8 minutes since beginning its emergency descent, 28 minutes since the circuit breakers had first popped. Cameron held the aircraft just above the runway, waiting for the right moment, then flared gently and let the main wheels touch down. The instant the wheels made contact, he deployed the spoilers, panels on the wings that destroy lift and push the aircraft down onto the runway, and stood on the brakes. But something was wrong. The aircraft wasn't slowing down normally. The anti-skid system, which prevents the wheels from locking up during heavy braking, had failed. When Cameron applied maximum braking force, the wheels locked solid and began SK. Retry F. Continue. Itting along the concrete runway, friction building up so much that the rubber began melting. The screech of locked wheels was audible even inside the smoke-filled cabin. One by one, the main landing gear tires exploded. First the left main gear tires burst with loud bangs, then the right side followed. The aircraft settled lower on its gear struts as the deflated tires offered no cushioning. Metal scraped against concrete, throwing sparks, but the aircraft was finally, mercifully, slowing down. Cameron kept the brakes locked, kept the spoilers deployed, using every available means to dissipate the aircraft's energy. The end of the runway was approaching, but they were decelerating. At last, roughly 2/3 of the way down runway 27 left, the DC-9 skidded to a complete stop. The time was 6:19 p.m. They were on the ground. They were stopped. Now came the most critical challenge: getting everyone off the aircraft before the fire consumed them all. Evacuation, 90 seconds to live or die. The moment the aircraft stopped moving, the cabin erupted into controlled chaos. Flight attendants leaped from their seats and rushed to the doors, shouting commands that would be seared into the memories of every survivor. Release your seatbelts. Come this way. Leave everything. Move. 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 Sergio Benetti reached the forward left door, door 1L in aviation terminology, and pulled the handle. The door swung open, and the inflatable evacuation slide deployed automatically, unfurling down to the runway surface. Fresh air rushed into the cabin, and for one brief, hopeful moment, it seemed like salvation. But that fresh air brought with it something deadly: oxygen. Throughout the flight, as the fire had burned behind the cabin walls, it had been generating combustible gases, the gaseous byproducts of melting plastics, burning insulation, vaporizing materials. These gases had been accumulating in the space between the cabin ceiling and the aircraft's outer skin, building up concentration, getting hotter, waiting only for the right conditions to ignite. The opening of the doors provided those conditions. Fresh air rushed in, creating airflow through the cabin and through the hidden spaces in the walls. The fire, which had been oxygen-starved, suddenly had all the oxygen it needed. But this disaster was still seconds away. For now, the evacuation was proceeding. Passengers stumbled forward, coughing, choking, eyes streaming tears, following the shouts of the flight attendants. Those seated near the exits helped others. The forward right door opened, its slide deployed. Passengers began sliding down to the concrete below, where airport fire crews were racing toward the aircraft. In the cockpit, Cameron and Ouimet were running through the emergency shutdown checklist. Fuel levers off. Engine start levers off. Battery switch off. Every step designed to remove potential ignition sources and make the aircraft as safe as possible. But their cockpit was so full of smoke they could barely see the switches they needed to operate. Cameron tried to stand, tried to move back into the cabin to help with the evacuation, but the smoke and heat drove him back. He could barely see 2 feet into the cabin. Ouimet, younger and perhaps slightly more resilient in that moment, managed to stagger a few steps aft, but he too was forced to retreat. They had no choice. Both pilots went back to their seats and opened the cockpit side windows, small sliding panels that could be opened on the ground. Fresh air poured in, giving them something breathable. Ouimet pulled himself through his window and dropped to the concrete below, where firefighters were positioning their equipment. Cameron tried to follow, but the ordeal of the descent and landing, the physical exertion of wrestling with the controls, the smoke inhalation, all of it had left him exhausted. He slumped in his seat, barely conscious. Ouimet, seeing his captain wasn't following, shouted to firefighters and directed them to spray foam on Cameron's window. The cold shock of the foam hitting the window and spraying through jolted Cameron back to alertness. With his last reserves of strength, he pulled himself through the window opening and fell into the arms of firefighters below. In the cabin, the evacuation was going as well as could be expected given the circumstances. Passengers who had been seated in the forward section were getting out quickly. The flight attendants were doing everything they could, physically pushing passengers toward the doors when they hesitated, supporting those who were barely conscious, maintaining order in a situation that could easily have devolved into panic. But passengers who had been seated further aft, even though they'd been moved forward during the flight, were struggling. The smoke was so thick now that visibility was measured in inches. People became disoriented, unable to find the doors even though they were just feet away. Some passengers, overcome by smoke inhalation, collapsed in the aisle. Others tried to help them, creating bottlenecks. The flight attendants kept shouting, kept pushing people toward the exits, kept the evacuation moving. But the clock was ticking. They'd been on the ground for perhaps 60 seconds now. The doors had been open for maybe 45 seconds. And then it happened. Flashover, when everything burns at once. Firefighters approaching the aircraft from outside saw it first. A sudden, violent change in the character of the smoke pouring from the open doors. It went from gray to orange-tinged, and then suddenly flames erupted from every opening. The cabin interior, which seconds earlier had been full of toxic smoke but not visible flames, exploded into fire. This is what fire investigators call a flashover, the moment when a fire transitions from the growth stage to the fully developed stage. The combustible gases that had been accumulating near the ceiling, heated beyond their ignition point, suddenly ignited all at once. The fire didn't spread through the cabin. It appeared simultaneously throughout the entire space, as if someone had flipped a switch. The temperature inside the cabin went from perhaps 150 to 200 degrees Fahrenheit to over 1,000 degrees in seconds. Everything that could burn began burning. Seat cushions, armrests, overhead bins, carpeting, wall panels, luggage in the overhead compartments. The cabin became a furnace. 23 passengers were still inside. Some had been trying to make their way forward and had become disoriented in the smoke. Some had collapsed and couldn't move. Some may have been trying to retrieve luggage from overhead bins, a tragically common behavior in aircraft emergencies, where people risk their lives for belongings. Some were trying to help others and ran out of time. The exact circumstances of each death would be investigated, analyzed, documented in the accident report. But the fundamental reality was simple and brutal. They were inside the aircraft when the flashover occurred, and no human being could survive in those conditions. The passengers still alive outside the aircraft, those who had made it down the evacuation slides in that critical first 90 seconds, looked back in horror as the aircraft they just escaped became fully engulfed in flames. Some had family members still inside. Some had been sitting next to people who hadn't made it out. The guilt of surviving when others didn't would haunt them for the rest of their lives. Firefighters aimed their hoses at the burning aircraft, pouring thousands of gallons of water and foam onto the flames. But it was far too late to save anyone still inside. Their job now was to prevent the fire from spreading to the wings and fuel tanks, which could cause an explosion that would endanger everyone in the area. The aftermath, counting the cost. By the time the fire was finally extinguished, the interior of the DC-9 was completely destroyed. The aluminum structure remained largely intact. Aluminum has a high melting point, but everything inside was gone, reduced to ash and twisted metal. The final toll was devastating. 23 passengers had perished in the fire. Among the dead were business travelers who would never return home to their families, a young mother traveling with her child, a newly married couple on their way to start their life together. Each of them had boarded Flight 797 expecting a routine flight to Toronto. None of them made it. 18 passengers survived, many with severe smoke inhalation injuries that would affect them for the rest of their lives. The 5 crew members all survived, though they would carry psychological scars from the experience. Captain Donald Cameron, First Officer Claude Ouimet, and flight attendants Sergio Benetti, Laura Kayama, and Judy Davidson had done everything they could with the training and equipment they had. They had gotten the aircraft on the ground. They had begun an evacuation. But the fire had simply been too fast, too hot, too overwhelming. The investigation, finding the truth. The National Transportation Safety Board, NTSB, launched an immediate investigation into the crash. The burnt-out wreckage of the DC-9 was transported to a hangar where investigators could examine every component, looking for the source of the fire and the reasons why it had proven so deadly. The cockpit voice recorder and flight data recorder, the black boxes, were recovered and analyzed. The voice recorder was particularly valuable, as it had captured not just the conversations between the pilots but also the sounds of the circuit breakers popping, the background conversations with flight attendants, and the mounting urgency as the situation deteriorated. One of the first questions investigators sought to answer was, where did the fire start? The most obvious possibility, A cigarette in the lavatory waste bin was quickly ruled out. Examination of the waste bin showed no evidence of the kind of burning pattern that would result from a cigarette fire. Moreover, witnesses had reported that the smoke seemed to be coming from behind the walls, not from the bin itself. Investigators focused their attention on the electrical systems in the aft lavatory area, particularly the wiring bundles that had been repaired after the 1980 decompression incident. These bundles ran beneath the lavatory floor and behind the walls, hidden from view. What they found was telling. In the area where the fire appeared to have originated, several electrical wires showed evidence of having been in contact with each other, their insulation worn away. This could have created a short circuit, a direct connection between wires carrying different electrical potentials, which would cause high current to flow, generating intense heat. The cockpit voice recorder had captured an electrical arcing sound just seconds before the circuit breakers popped. This arcing, the sound of electricity jumping across a gap, was consistent with a short circuit. The theory began to come together. Damaged wiring beneath the lavatory floor had short-circuited, generating heat, which ignited nearby insulation and other materials. The fire had started behind the walls and floor, where no one could see it and where the fire extinguisher couldn't reach it. But investigators couldn't prove this theory with absolute certainty. The fire had been so destructive that much of the evidence had been consumed. They could identify the area where the fire started and the likely mechanism, but they couldn't point to a specific wire and say, this one caused it. What they could say with certainty was that the fire had started in a hidden area, had burned undetected for several minutes, and had spread through the aircraft structure in a way that made it impossible to extinguish with the equipment available to the crew. The systemic failures, how the industry failed Flight 797. As the investigation progressed, it became clear that this wasn't just a story of one aircraft with a wiring problem. It was a story of systemic failures in how the aviation industry thought about and prepared for in-flight fires. The lack of smoke detectors. In 1983, commercial aircraft were not required to have smoke detectors in their lavatories. The assumption was that fires would be visible, either flames or smoke emerging from the waste bin, and that crew would notice them quickly. Flight 797 proved this assumption catastrophically wrong. A fire burning behind walls wouldn't produce visible flames, and the smoke it produced might not be noticed immediately, especially in a busy cabin during meal service. Those critical early minutes when the fire might have been manageable were lost because no alarm sounded. Inadequate firefighting equipment. The halon fire extinguishers carried on the aircraft were designed for fighting fires in open spaces, waste bins, seat cushions, galley areas. They were completely ineffective against a fire burning in a concealed space. Moreover, the crew had no tools to access those concealed spaces. The flight attendants had a crash axe, but they weren't trained on which panels could be safely removed to access hidden fires, and removing the wrong panel might damage critical flight control cables or other systems. No breathing protection. The pilots had oxygen masks, but these were designed for use in a decompression, not in a smoke-filled environment. The flight attendants had nothing at all. No smoke masks, no self-contained breathing apparatus, nothing that would allow them to work in the toxic smoke that filled the cabin. First Officer Ouimet's attempt to reach the lavatory early in the emergency was thwarted simply because he couldn't breathe in the smoke. If he'd had proper breathing protection, he might have been able to confirm the fire's location and seriousness earlier, potentially leading to an earlier decision to divert. Inadequate emergency lighting. When the smoke filled the cabin, passengers became disoriented. Many couldn't find the exits even though they'd been moved to the forward part of the cabin, relatively close to the doors. The aircraft had emergency lighting, but it consisted of small lights mounted at seat level and on the exit doors themselves. In dense smoke, these lights were nearly invisible. Passengers literally couldn't see the way to safety. Training gaps. The crew's training had prepared them for waste bin fires and other visible fires, but not for a hidden fire of unknown origin. Captain Cameron's decision not to immediately divert was influenced by conflicting information and by his training's emphasis on waste bin fires as the most common scenario. The flight attendants' decision not to break through the lavatory walls to reach the fire was influenced by their lack of training on which panels could be safely removed. Air conditioning pack misunderstanding. First Officer Ouimet's decision to turn off the air conditioning packs was well-intentioned but based on a misunderstanding of the systems. He believed he was starving the fire of oxygen, but he was actually eliminating the only means of clearing smoke from the cabin and cockpit. This lack of understanding about how aircraft environmental systems work in fire scenarios represented another training gap. Material flammability. The cabin interior of the DC-9, like most aircraft of that era, was full of materials that were flammable and that produced toxic smoke when burned. Seat cushions, wall panels, insulation, carpeting. All of these could burn and all produced deadly gases including carbon monoxide and hydrogen cyanide. Modern aircraft use more fire-resistant materials, but in 1983, this wasn't a priority. The recommendations: changing aviation forever. The NTSB's final report on Air Canada Flight 797 included numerous recommendations, many of which would fundamentally change how aircraft are designed and how crews are trained to deal with fires. Lavatory smoke detectors. The most immediate and obvious recommendation was that all commercial aircraft lavatories must be equipped with smoke detectors. These detectors would provide early warning of fires, giving crews precious minutes to respond before the situation became critical. This recommendation was implemented quickly, and today, lavatory smoke detectors are standard on all commercial aircraft worldwide. Floor-level emergency lighting. The NTSB recommended that aircraft be equipped with floor-level emergency lighting that would remain visible even in dense smoke. These lights, typically installed at or near floor level along the aisles, provide a visual path to the exits. Modern aircraft have sophisticated emergency lighting systems with photoluminescent strips that glow in the dark, battery-powered lights that activate automatically in emergencies, and lighting that specifically marks exit rows and paths. Smoke masks for crew. The NTSB recommended that aircraft carry protective breathing equipment, PBE, for crew members, essentially smoke masks with their own air supply that would allow crew to work in smoke-filled environments. These are now standard equipment on commercial aircraft. Flight attendants can don these masks and continue fighting fires and assisting passengers even when the cabin is full of smoke. More fire extinguishers. The number and type of fire extinguishers carried on aircraft was increased, and crews were given more training on accessing concealed spaces where fires might be burning. Improved fire-resistant materials. The investigation prompted a broader look at materials used in aircraft interiors. New standards were developed requiring that cabin materials be more fire-resistant and, crucially, produce less toxic smoke when they do burn. This has been an ongoing evolution, with each generation of aircraft using progressively safer materials. Immediate emergency response procedures. Perhaps the most important recommendation was a change in how crews are trained to respond to fire indications. Before Flight 797, the procedure was to assess the situation, fight the fire if possible, and divert if necessary. After Flight 797, the procedure became, at the first indication of smoke or fire, begin an immediate emergency descent and divert to the nearest suitable airport. All assessment and firefighting happens during the descent, not before it begins. This change in philosophy recognizes the stark reality revealed by Flight 797 and other similar accidents. Once a fire is established on an aircraft, the crew has perhaps 15 to 20 minutes before the situation becomes uncontrollable. There's no time to diagnose, no time to troubleshoot, no time to hope the situation will improve. The only option is to get the aircraft on the ground as quickly as possible. Air conditioning pack procedures. Training was updated to ensure crews understood that shutting off air conditioning packs during a fire does more harm than good. The packs should remain on to help clear smoke from the cabin. Evacuation training. The investigation revealed that many passengers hadn't found exits quickly enough, and some may have delayed evacuation by trying to retrieve belongings. Enhanced evacuation training for passengers, clearer announcements about leaving everything behind, and better crew training on managing evacuations all resulted from these findings. The human factor, understanding decision-making under pressure. Beyond the technical recommendations, the Flight 797 investigation contributed to a broader understanding of human decision-making in emergencies, particularly the concept of confirmation bias that influenced Captain Cameron's actions. Cameron was an experienced, competent pilot who made reasonable decisions based on the information available to him. But he was also human, and humans process information through filters of expectation and experience. When he heard about a fire in the lavatory, his experience told him waste bin fire. Every piece of information he received was unconsciously filtered through that expectation. Reports that the smoke was clearing reinforced his belief that the fire was under control. The aircraft's history of electrical problems gave him an alternative explanation for the system failures. None of this was negligence or incompetence. It was normal human psychology operating under conditions of extreme stress, time pressure, and ambiguous information. The lesson for aviation, and indeed for any safety-critical industry, is that procedures and training must account for these human factors. They must guide people toward correct decisions even when their intuitions might lead them astray. This is why the immediate descent procedure is so important. It removes the decision-making burden in those critical early minutes. Smoke or fire, descend immediately. Don't assess, don't troubleshoot, don't wait to see if it gets better. Just descend. This procedure recognizes that human judgment under these conditions is unreliable, and it provides a simple, clear action that's almost always the right choice. The legacy: lives saved by lessons learned. The changes prompted by Air Canada Flight 797 have undoubtedly saved lives in the decades since. There have been subsequent incidents of in-flight fires, but the improved detection systems, better firefighting equipment, more effective training, and immediate descent procedures have allowed crews to get their aircraft on the ground before reaching the point of uncontrollability. Consider Singapore Airlines Flight 286 in 1998, when smoke was detected in a lavatory. The crew immediately began an emergency descent and diverted to the nearest airport, landing safely with no injuries. The early warning from smoke detectors and the immediate response procedure, both legacies of Flight 797, prevented what could have been another disaster. Or Swissair Flight 111 in 1998, which tragically crashed into the Atlantic Ocean off Nova Scotia after an in-flight fire. While the outcome was devastating, all 229 people on board died. The investigation of that accident built upon lessons from Flight 797, leading to further improvements in fire detection, fighting, and response procedures. Each accident, each investigation, each set of recommendations contributes to the collective safety knowledge of the aviation industry. This is why commercial aviation, despite occasional tragedies, has become statistically the safest form of transportation ever devised by humanity. The industry learns from its failures, implements changes, and becomes progressively safer, remembering the victims. Behind all the technical analysis, the safety recommendations, and the procedural changes are 23 people who lost their lives on June 2, 1983. They deserve to be remembered not just as statistics or case studies, but as individuals with families, dreams, and futures that were taken from them. There was Cameron Ordold, just 19 years old, traveling home to Toronto. Helen Ruddock, a grandmother visiting family. Manjinder Kaur, a young mother traveling with her infant son, who both perished in the fire. Business travelers like Michael Nazello and Michael Vines. Students like David Fraser. Each one boarded Flight 797 expecting to arrive in Toronto that evening. Each one trusted that the aircraft was safe, that the crew was prepared for any emergency, that the systems designed to protect them would work. They were let down not by the crew, who did everything they could with the tools and training they had, but by a system that hadn't fully appreciated the deadly nature of hidden fires, that hadn't equipped aircraft with adequate detection and suppression systems, that hadn't established procedures for immediate response. Their deaths were not in vain. The changes made after Flight 797 have protected countless others in the years since. But that's cold comfort to the families who lost loved ones that day, who still live with the absence of people who should still be alive. Conclusion: the ongoing quest for safety. The story of Air Canada Flight 797 is ultimately a story about the complexity of aviation safety and the constant vigilance required to maintain it. Aircraft are incredibly complex machines operating in an unforgiving environment. They're designed with multiple redundancies, with safety systems layered upon safety systems, with procedures and training refined over decades. And yet, sometimes a confluence of factors, A hidden wire short, a fire in a concealed space, ambiguous information, human psychology under stress, can defeat all of those protections. The aviation industry's response to such events determines whether they remain isolated tragedies or become catalysts for improvement. In the case of Flight 797, the industry chose improvement. The investigations were thorough, the recommendations were comprehensive, and most importantly, they were implemented. Smoke detectors in lavatories became mandatory. Floor-level emergency lighting became standard. Protective breathing equipment for crew became required. Immediate descent procedures were established. But the work is never finished. Even today, aviation safety experts continue to study fire risks on aircraft, to develop new detection and suppression technologies, to refine training and procedures. The quest for perfect safety is asymptotic. We can approach it but never quite reach it. But every improvement, every lesson learned, every life saved justifies the effort. For Captain Donald Cameron and First Officer Claude Ouimet, the memories of that day never fully faded. Cameron would later say that he replayed the flight countless times in his mind, wondering if there was something different he could have done, some decision that might have saved more lives. This is the burden carried by survivors of disasters, the weight of wondering what if. But the objective analysis shows that Cameron and his crew performed remarkably under impossible conditions. They got a badly damaged, instrument-failed aircraft on the ground when many pilots might not have. They initiated an evacuation that saved 18 lives. They did everything their training had prepared them to do. The failures were systemic, not individual. The true lessons of Flight 797 are these. Safety requires constant vigilance. Procedures must account for human limitations. Equipment must be designed for the worst-case scenario, not the most common one. And every accident, no matter how tragic, must be studied, understood, and used to prevent future tragedies. Today, when you board a commercial airliner and see the smoke detector in the lavatory, or notice the floor-level emergency lighting along the aisle, or hear the flight attendant mention that crew have special equipment for fighting fires, remember Flight 797. Remember the 23 people who didn't make it home that day, and remember that their tragedy led to changes that have protected millions of others in the decades since. This is how aviation safety progresses, not by achieving perfection, but by learning from imperfection, by refusing to accept that any accident was inevitable, and by constantly working to ensure that the mistakes of the past don't become the tragedies of the future.